Welcome back, everyone. This is a GRE Prep Hour. I am Tyler Johnson, and I'll be your host today. I am an instructor and a tutor with Manhattan Prep, and I like these free prep hours because they're an opportunity for me and the other instructors to kind of take deeper dives on topics that we often don't get the time to cover in the courses that we teach. And today's lesson, we are doing an hour on picking numbers for the quant section. And if you're joining on YouTube, welcome. But just so you know, this is also happening live in Zoom right now. So if you would like to attend one of the live Zoom meetings in the future, there should be a link in the description down below. To everyone in the room live with me right now, go ahead and in the chat box, chat me where in the world you are connecting from. I am joining from San Francisco, California right now, where it's often foggy, but it's a pretty hot, sunny day today. All right, we got Chicago, Pennsylvania, Boston, some East Coast. We got Seattle on the West Coast, Augusta, Georgia in the South, Southern Illinois. Great. Well, welcome to all of you. Happy to have you here today. And one thing I want to say, oh, we got Nigeria in the house as well. Welcome, welcome. One thing I want to say about the GRE, a common misconception, is that it is not a math test, right? The quantitative section of this test is a quantitative reasoning test. As such, I think the exam tends to reward those that can get away from kind of the crunchy algebraic approach and experiment with some of these more experimental, alternative, kind of creative strategies. And that's including things like estimating, working backwards from the answer choices, thinking logically, and just kind of making eliminations of what is an impossibility within the answer choices, and using visualizations. And my favorite, and what we're talking about today, picking numbers. And picking numbers is something that comes fairly intuitively for quantitative comparisons. That's something y'all should definitely use when it comes to QC problems. That's not what we're going to talk about today, but if that's something you're unfamiliar with, definitely Google quantitative comparisons, picking numbers. There's a bunch of material on that out there. But I'm going to go over some less common ideas when it comes to picking numbers for multiple choice types of questions. And just to kind of toss you off into the deep end, I'm going to show you all a problem to start. I'll give you about 3 minutes to work on it. And if you're in the room live with me now, chat me your answer when you're done. And yeah, as for this first one, if you want to approach it algebraically, you're welcome to, but I'll tell you that picking numbers can make this one a lot simpler. And if you're confused on what that means, we'll get to it in a couple minutes when we come back and look at the solution together. So here you go. I'll give you about 3 minutes here. All right, it's been about 3 minutes, so let's take a look at the picking numbers solution here. The first thing I want to talk about is just the trigger to acknowledge that it's possible to pick numbers here. And that is every value presented in the problem is a relative fraction. Right, I've got half as many books as Millicent, and then Harold's bringing 1/3 of those books, and Millicent's then going to bring 1/2 to the new library. There's no hard-coded number in there. All of it is just a relative fraction. So whenever you notice everything is relative, that's an opportunity to pick some numbers. And in the case where everything is fractions, the easiest move you can make there is to multiply the denominators together. So you've got halves and thirds, multiply them together, you're going to get 6. And that's going to be your kind of starting place. The reason you do that is when you're picking numbers, you want to make the math easy, right? So you want to pick the simplest numbers you can. Multiplying those denominators is going to ensure that after you use that number, everything else in the problem is going to become an integer. So 2 times 3 makes 6 books. I'm going to say then that Millicent has 6 books at the old library. Harold has half as many, so Harold will have half of 6, or 3. And then from there, I'm just going to start building out the other pieces of the problem. So at the new library, Harold is going to bring 1/3 of his books, so he's just bringing 1. And then Millicent is bringing half of her books, so she's bringing 3. So altogether, there are 4 books in that new library. And the ultimate question, what fraction of Millicent's old library is the new home's capacity? So I want that new library total over Millicent's old total, and that's going to give you 4 out of 6, which simplifies to 2/3. And in my opinion, that is the easiest approach you can take for this problem. It's definitely possible to apply some algebra here, but I think it's a little more long-winded. It's going to take you some more time. It's not as efficient. And I think you leave yourself more open to making some careless mistakes. That, in your scratch work, when you're writing things along, it's really easy to just miswrite a number or misplace a plus sign, some careless mistake like that. So whenever possible, I reach for picking numbers. When I see that opportunity, that's going to be my go-to. So that's the situation when you've got relative values and everything's a fraction. I want to show you another problem where instead of fractions, we're now dealing with percents. I'll give you another 3 minutes here. Chat your answers when you've got it. So here's another situation where they never tell you a hard-coded flower amount. It's all just these relative percents. When you're in that situation, I think the easiest move to make is to either use 100 or 10 in the problem, because 110 numbers like that are going to play really nicely when it comes to percents. But you have to be careful about what value you're assigning to be that 100 or the 10, because say I start with 100 being my total number of flowers, then I'm going to have equal parts red and equal parts pink, white, yellow. So I'd have 50 red and 50 pink, white, yellow. But then I get this issue when I look at the individual pink, white, and yellow amount that each of those would be 50 thirds. And the whole purpose of picking numbers is to choose values that are simple, that make the math easy. But here I have this non-integer kind of ugly fraction, 50 thirds. So rather than make the total 100, I think what's going to make the math simplest here is to make the pink, whites, and yellows each 100. So that way I'd get 300 on the pink, white, yellow half, 300 on the red half, and 600 total. Once I've got that set up, I need to start calculating those percentages. So if 70% of my 300 red flowers are sold, well, 10% would be 30. So scale that up by 7 to get 70%. You know that 210 would have been sold in that case. For the pink, whites, and yellows, here's where that 100 comes in really handy. Percent is the literal number of flower in each of those cases. So now I need to figure out the total sold from everything. So I'm just going to sum up my sold values. And the ultimate question is what percent of the total roses were sold? So I'm going to take that 360 I just summed up and divide that by the number I started with, 600. And that's going to come out to D, 60%. So if you notice, everything's relative. If it's fractions, multiply those denominators together. That's going to give you a good starting value. If everything is a percent, 10 or 100 are going to be the easiest numbers you can pick. Let's see another case where you can pick numbers. See if you can figure this one out. Got 3 minutes. So here's another scenario where I can pick numbers. It's when I notice in my answer choices, I've got the same variables in every single one. And if you aren't doing this on quant, before you start a solution, always check out the answer choices. Take a peek so you get a sense of what you're working with. Here, everything is in terms of X and Y. So the picking number strategy I want to use is something called pick for Vic, where Vic, VIC, that stands for variables in the choices. And what I want to do is I'm going to assign numbers to the variables in my question stem, right? The start of the question over there. And I'm going to see what pops out of that stem. When I give it some numbers, then that's going to be my target. And for this particular problem, there's no restrictions on X and Y. I'm not told that X and Y are different or they cannot be equal to each other, anything like that. So making the numbers as easy as I can, I'm just going to say X and Y are both 1. And if I plug in 1 for all those variables and evaluate my question stem, I see the stem is equal to 4. So that's my target value. And the last step here is I'm going to plug in X and Y being 1 to every one of these answer choices until I get an answer that also produces 4. So going through, A doesn't work, that would give you 0. B doesn't work, you get 2. C, you also get 2. D, you get 4. But you got to be careful with this technique. You may get a false positive, so it is important to check every answer choice. But I check E, and that one is not equal to 4. So I've proven that D is the only correct answer here. And should you run into a scenario where you do get a false positive and there were 2 answers both producing 4, what you would do is go back to the numbers you pick and just make them different. Right? Maybe it's the fact that I had X and Y being the same exact value that created 2 answers giving me the same result. So maybe I'd try like X being 2 and Y being 1, or make them weirdo and do like X is 5 and Y is 3. Just do a different trial, and that should whittle it down until there's only 1 answer choice remaining. And if you're curious on this one, if you wanted to solve it algebraically, this one's tricky because you would have to spot that square of a sum pattern, right? That is really what unlocks this whole one. And I think that's pretty tricky to see. But if I saw something like this, I wouldn't try and do it algebraically to begin with. I'm just going to plug in simple values for X and Y, get my target, plug the same thing into the answer choices until I find a match. Okay, here's another problem. This one's involving rates, and it's one of those fill in the blank types. You got 3 minutes. When I've got a rate problem, that is work rate or distance, one of my favorite ways to stay organized is using one of these tables. So rate times time is going to equal the distance. And we're given two rates in the question stem, 50 and 60. They never actually mention what the distance is, but you do know it's the same route back and forth. So from A to B, I could just call that a generic D miles, and then it's also going to be D miles from B back to A, and then the round trip is going to be 2D miles. But anytime you introduce a variable, it's adding more complexity to the problem. So rather than introduce another variable here, what's going to be easier is just to recognize that that D component is present in every row of my table. So instead of using a variable, I'm going to swap that out for a smart number. And the best number to choose in these cases, when you're substituting in for something, for a distance or for an amount of work, is you want to pick a multiple of the numbers that are involved, right? Because it's R times T that makes D. So you want either a multiple of R or a multiple of T. And that 300 right there, that's going to play real nicely with the 50 and 60 that we already know. And then don't forget that your round trip is double that single distance amount. So in that first row, if 300 miles were covered at a rate of 50 miles per hour, they must have been traveling for 6 hours. And in the second row, 300 miles at 60 miles per hour, that would be 5 hours of travel time. And then remember, for average speed, your definition there, if you're unfamiliar, is it's always total distance divided by total time. So time was a total of 11 hours, distance was a total of 600 miles, so average speed is 600 divided by 11, rounded to the nearest tenth, that's going to be 54.5. So when it comes to rates, this is a common setup you'll see where they don't tell you the total distance or the total work amount, but don't make it a variable. Just pick a number that's going to play nicely with the numbers they do tell you. Okay, I'm going to show you a few problems that are kind of riffs of what we've already talked about, but I want to see if you can take some of these concepts and apply them to some new stuff you haven't seen yet. So go ahead and try this one out. So the trigger in this problem is that everything is a relative fraction. I've got 1/5 and 1/4. So I want to start by multiplying those two denominators together. I get 20. That's going to be my starting point here. So I'm going to say initially that stock has a price of $20. And then if it increases by 1/5, that new price will be 24. From there, if the $24 price decreases by 1/4, 1/4 of 24 is 6, so that'll go down to 18. And now make sure you read carefully. The final question here is, what was the ratio of the stock price at the end of the 2 months to the original price? So I got my price at the end, 18 over the original 20. That reduces to 9/10. That is choice A. Here's another one. We're going to take a look at a quantitative comparison next. Try it out. Everything here is a relative percent. So picking 10 or 100 is probably the easiest thing I can do here. And I'm going to start with that big circle. and say that the diameter is 10. And another trick for you, anytime I'm dealing with circles, one of the first things I'd like to do is just write R, D, C, and A on my scratch paper. That's going to represent my radius, diameter, circumference, and area. Because typically, you're going to start with one of those pieces of information. And then as soon as you know one, you can calculate the other three. So here I know diameter is 10, so radius is going to be half that. Circumference is diameter times pi, and area is the radius squared times pi. And now I'll think about that smaller circle. Its diameter is 60% of the larger circle. So in this case, because I picked 10, its diameter is going to be 6. And then I'll RDCA that out again. And then looking at quantity A, they're asking for the area of just that shaded kind of donut shape. Anytime you're looking for the area of a weird shape like that on the GRE, it's typically a matter of either adding or subtracting the areas of two more familiar shapes. So in this case, I subtract the areas of my two circles. That's going to leave that donut behind. And with the RDCA trick, I already know the two areas of my circles. So 25 pi minus 9 pi gives me 16 pi. So quantity A is taken care of, but quantity B, I've got another circle to draw. This has a diameter 80% of the initial circle, so 8. And if you RDCA that, you will also get 16 pi. So quantity A and quantity B are both equal, and the answer is C. We're going to look at another problem next. We haven't really talked about this rule, but I would encourage you, keep number picking in mind. That's the theme of this whole lesson. See if you can crack this next one. So a lot of people, when picking numbers for these sorts of odd and even questions, are going to default to 1 and 2. But in my opinion, there's an even easier number set that is 1 and 0, right? So 0, it's neutral when it comes to positivity versus negativity, but in terms of odd versus even, 0 is an even number. So whenever I see odds and evens, rather than thinking abstractly about, what happens when I multiply an odd by an even or subtract an odd and an even, it's much easier for me to make it more concrete and just plug in a 0 for every even value and plug in a 1 for every odd value. And we start with this description that m squared minus n squared has to be odd. And I'm just going to quickly think about the different scenarios if m were 0 and n were 1 or vice versa. And what you'll see is if they're both 0, you'd get another even. That doesn't work. If they're both 1, you get an even. That doesn't work. It's when they're opposite. So one must be odd and the other must be even. So I'm going to evaluate each one of these answer choices using that logic, right? M plus n. In either case, as long as 1 and the other is 0, that does produce another 1. So I know that's always an odd output. And A is correct. Choice B, if I have m squared plus mn. So in this case, if my m is 1, that's going to produce something odd. But if my m is 0, that's going to produce something even. So that is not always producing an odd. Remember, we're looking for something that must always produce another odd value. So B is out. How about n squared plus mn? So I could have a 0 squared plus 0. That would work. Or I could have a 1 squared plus 0. And that's not going to work. So that one is eliminated as well. M squared n, at least one of those is going to be 0. So here it's either going to be a 0 plus a 0. And if I swap them around, I'd get a 0 plus another 0. So that one's consistent, but it's outputting an even every time. And I want the one that produces an odd every time. So D is out. Looking at E, if my m is 0, I get 0 plus 0 plus 1 squared. That one's going to work. Now I swap it around. What if I make m 1? Well, then I'm going to get 1 squared plus 0 plus 0. That one is also 1. So both those situations are producing another odd. That one is correct. Finally, m cubed plus n cubed. I'd either have 0 cubed plus 1 cubed. That works. Or it could be 1 cubed plus 0 cubed, and they both work. So those are the only 3 answers. The first one and the last 2. So odds and evens, best thing to do. Plug in 0 for any even and 1 for any odd. Okay, here comes another question. We haven't spoken about this specific scenario yet, but it is similar to something else we've talked about. So see if you can figure it out on your own. We'll talk about it in about 3 minutes. So first off, there's a bit of logic here to recognize the ultimate question is P times X equals which of the following, and it's a multiple choice question. So only one of these can be a valid answer. And if P times X is only ever equal to one single value, then that tells you X is a constant. That is, X is only a single number, but the test writers have chosen to represent that number in this really roundabout, complex way in terms of n. But if it's only ever one number, that means you can choose your own value of n, and then X should always be spitting out the same constant. So I call this situation the complex constant, and you're just going to swap the variable for a simple number. So instead of X being this whole long thing that, yeah, I could evaluate that algebraically, but it would be a big pain. Instead, I'm just going to say, what if n is equal to 1? So plug in a 1 for every instance of n there. That first initial term, that whole fraction there is just going to become 0. And then I've got minus 1 minus 1 over 1 plus 1 times 1 plus 1 over 1. But yeah, swapping out that n for a 1, already things start to look much, much simpler. And I'm just going to keep evaluating for X until I see that X itself is -1. And combine that with the information that P is -1. And you know P times X is -1 times -1, which is +1. And that is choice D. So it's pretty similar to pick for Vic, except none of the answers have variables. All the variables are appearing in the question stem. But if you see a humongous algebraic expression like that, right? This is not a math test. They're not trying to battle to see who can do the craziest mathematics in 3 minutes. They're trying to see who can unlock these problems, who can look for these quick, quantitative logical tricks to implement. And yeah, here it's noticing that everything's a constant. That means n could be any value. So why not make n the simplest value it could be? Okay, one other situation that we haven't yet talked about is gonna involve remainders. So this will be our last question of the day. See if you can figure out a solution to pick some numbers to get this remainder answer here. Good luck. Okay, so we start with two pieces of information that when you divide x by y, you get some value with a remainder of 6, and you divide a by b, you get some value with a remainder of 9. And when it comes to remainder questions, I think the easiest place to start is the situation where the quotient is 0, which is kind of a weird thing to think about it. It doesn't happen a whole lot in every day, or not even in a lot of math that you might do out of a textbook, but it looks something like this. If m is a bigger number than n, then n over m is going to be 0 with the remainder equal to n. Now that sounds kind of complex when I say it with variables, but if I do something like this, if I have 10 and I divide it by 20, right? 20 fits into 10 0 times. It doesn't fit into 10, and then I still have 10 left over. So now with x, y, and a and b, I'm basically just trying to make the smallest divisor there that I can. So if I want the remainder to be 6, I'm just going to say x itself is 6, and a itself is 9. And what's the next biggest number that won't fit into 6? Well, that would be 7, right? 7 does not actually fit into 6. So I'm going to get 0 with 6 left over. And what's the lowest number that doesn't actually fit into 9? That would be 10. 9 divided by 10 is going to be 0 with 9 left over. And then I'm looking for possible values of y plus b. So at the absolute minimum case here, I've seen that y could be 7 and b could be 10. But that's the lowest that number could ever be. Right? If I squash everything down so that my quotient is 0, absolute smallest I could ever have y plus b turn out to be is 17. Therefore, choice E, 15 is the correct answer. I could have 17 or numbers above that, but I could never have something smaller than 17. So in terms of number picking, when you've got these remainder problems, pick 0 as your quotient. That's often the easiest place to start. And in that situation, your dividend and remainder are going to be the same value. Okay, so that was our last problem. We're going to wrap up and just talk about what we covered today. One of the first techniques we discussed was when you've got variables in every single choice. What you can do there is you want to plug into the question stem first, get that target value, and then plug the same exact values into every answer choice until you get a match. If you get multiple matches, that just means pick some new numbers and test the two that remain until only one works. When you've got relative values, we've seen a few riffs on that, right? If everything's a fraction, multiply your denominators together. That's going to give you the lowest number that is still going to produce integers in the end. If you've got percents everywhere in the problem, I would say using 100 or 10 is the best way to go, because taking 10% of 100 or 10% of 10, any percent of those numbers is going to be a pretty straightforward process. And when it comes to rates, right, work rates or distances, a lot of these problems won't give you an actual distance or an amount of work. Just replace, or instead of assigning a variable to the distance of the work, make it a multiple of the rates or the times involved. That also is going to make everything become a nice integer in the end. And when we saw that problem with p and x and n, If you have a really complex constant in that stem, that's just a really roundabout, overly complex way of writing a constant. So pick your own easy number. Usually subbing in a 1 or a 2, some low value like that will be enough so that you can evaluate what that number actually is without the need to do a bunch of messy algebra. And then odds and evens. 1 and 0, not 1 and 2, 1 and 0, I think is the way to go there. And finally, if it's a remainder problem, start with your zero quotient scenario where the dividend and the remainder are the same. All right, that's going to do it for us today. If you enjoyed this little lesson, I welcome you to go to that link on screen. If you're watching on YouTube, there should be a link in the description to the same place. And I just pasted that link into the chat box here in the live Zoom room. But if you go to that link, you'll see the other upcoming free prep hours if you want to check out another one of these. Or alternatively, we also open session number 1 of our 9-week course up to the public. So if you want to check out a 3-hour lecture, I encourage you all check out session number 1. I actually have one coming up later next week if you want to check that out. But in any case, we'd love to see you again at another event in the future. So go to that link, check out what's happening, and come see us again sometime. All right, I'm going to go ahead and stop the recording. Thanks for joining. And if you're in the chat and you have any other questions, I can